So chlorine is going to attract the electrons because it's more electronegative, and carbon is going to get del positive, and in the same way chlorine will get del negative. Okay, so we are having two ways by which the fission is going to take place. Okay, so we will see what is the possibility of fission to happen, heterolytic fission to happen. So in the first case, you can see, I'm talking about this case. You will see here carbon has got negative charge and chlorine has got positive charge, but we know that's not possible because chlorine is more electronegative. So it's not possible that carbon will take electrons by itself, because chlorine is more electronegative than chlorine is sorry chlorine is more electronegative than carbon. So it's the first case is not possible. It is showing, it seems like carbon is more electronegative, but that's not the case. In other case, we are seeing like chlorine is taking the two electrons while doing the fission. Chlorine is taking electrons with itself, and carbon is having the positive charge on it. So we can say this type of fission, heterolytic fission, is possible because here we can see like all the rules are being followed up. Like we know carbon is less electronegative, so in the same way fission has happened. So first one is the wrong way to do heterolytic fission, and the second one is the right way. Okay, and this compound, you can see the thing that has been formed here is the carbocation, or we can also call it as carbonium ion. After that, we will study something about carbocation. What is carbocation? Okay, carbon having sextet of electrons in valence shell with positive charge. So carbon having sextet of electrons. Sextet of electrons means 6 electrons in valence shell. So here you can see this is also the carbocation as it's mentioned below. So it's having sextet of electrons, 6 electrons in valence shell. You can count, these are 6 electrons that are surrounding the carbocation. Okay, and with positive charge, it's written here like with positive charge, and here we can also see there's a positive charge because 2 electrons are missing. This octet is not completed, so it has got positive charge. All right, so after that, you can see we are having some examples of like we are having methyl cation, isopropyl cation, and then we are having vacant p orbital. Okay, so some properties of carbocation, that is sp2. It has a sp2 hybridization. If you see the hybridization of this, you can say it has sp2 hybridization because 3 bonds are, and there is a vacant orbital in it, vacant p orbital, and it has a trigonal planar. You can see the shape of it. It's trigonal planar, the geometry is trigonal planar, and 6 electrons are in valence shell. We are talking about carbocation, and we are having incomplete octet. That means octet is not completed here, so it's incomplete octet. And electrophile, from the one which we electrophile, that means the one which takes the electron, so that we call as electrophile. Or we can say जो electron लेता है, I have also written it there, you can also write it on your own notebooks. जो electron लेता है उसको हम electrophile कहते हैं. And in the same way, it's a Lewis acid. Lewis acid, the one that accepts a pair of electron, that is known as the Lewis acid, and it has a vacant p orbital that is shown in the diagram. You can see the vacant p orbital here, which is perpendicular to the plane of molecule. That means this vacant p orbital is perpendicular to the plane of molecule. It's perpendicular, it's already shown here, it's perpendicular to the plane of orbital. So this was all about heterolytic bond fission, and what we studied is carbocation. Thank you so much.